In question 4, we have three 3.5 kilowatt storage heaters connected to a 230 volt supply. In A part 1, we're to show that the resistance of each heating element is about 15 ohms when the heater is operating at 230 volts. Well, for this we can use power is equal to V squared over R. So R is equal to V squared over power, which is 230 volts squared over 3,500 watts. This comes out at 15.11 ohms, which is around 15 ohms as required. In part 2, we're told the element is constructed from a metal of resistivity 1.6 times 10 to the minus 6 ohm meters with a radius of 0.55 millimeters. We're to find the length of wire in one element. Well, resistance is equal to resistivity times length over area. So length is equal to resistance times area over resistivity, which is a resistance of 15 ohms, 15 ohms, times the area is pi times 0.55 millimeters, or times 10 to minus 3 meters squared, over the resistivity of 1.6 times 10 to minus 6 ohm meters. That gives a length of 8.9 meters. In part 3, we're to state and explain whether the heater obeys Ohm's law. Well, Ohm's law states that current is directly proportional to potential difference as long as the temperature remains constant, and in this case the temperature is not constant as it's a heater, so it will not obey Ohm's law. In B, we're told the cost of 1 kilowatt hour is 7.6 pence and asked to calculate the cost of using the 3 storage heaters between midnight and 7 AM every night for a week. Well, we have 3 heaters at 3.5 kilowatts times 7 hours per night times 7 nights times 7.6 pence per kilowatt hour. That comes out at 3910p, or £39.10p. In C part 1 we have another circuit, and we're told when the temperature of the thermistor is 12 degrees C it has a resistance of 6.8 kiloohms, and we're given the variable resistor's resistance at 1.4 kiloohms. We're asked to calculate the reading on the voltmeter. Well, for this we can use V out is equal to R2 over R1 plus R2 times V in. But in this case we have 3 resistors, so it will be R1 plus R2 plus R3. R2 in this case is the resistor that we're measuring the potential difference across. So now we can have the resistor, the fixed resistor is 1.1 kilo ohms, and then we have the fixed resistor again at 1.1 times 10 to the 3 plus the variable resistor at 1.4 times 10 to the 3 plus the thermistor at 6.8 times 10 to the 3. And this is all multiplied by the input voltage of 6 volts, giving a potential difference of 0.71 volts. In part 2, we're to explain how the reading on the voltmeter will change when the temperature of the thermistor increases. Well, the resistance of the thermistor will go down as its temperature rises, and therefore the total resistance of the circuit will also reduce. This will mean the current in the circuit will rise, so we must have a higher potential difference across the fixed resistor, so the voltmeter reading will rise.